Alright, today we're going to discuss the Pythagorean Theorem and how it works. Okay, the Pythagorean Theorem is probably the most applicable piece of math you'll use in your life if you become, let's say you become a carpenter or like a guy that builds a house. Okay, anything like that, a bridge builder, anything like that, you'll use this. Okay. First, you need to know what the hypotenuse and what the legs of a triangle are. Okay. So if we've got this triangle right here, and we say that this is a 90-degree angle, let's call this triangle A, B, and C. Okay? Now it says right here the longest side of the right triangle is the hypotenuse. So which side is the hypotenuse, Kevin? A what? That's an angle. A what?
C.
AC. So this right here is the hypotenuse. Okay? Now, what is AB and BC called? What are AB and BC called? Legs. This is a leg, and this is a leg. A side can't be an angle, Chris. I asked what AB was. That's a side. You said a right angle. A side can't be an angle. Now, angle B is a right angle, which means it equals 90 degrees. Okay? But right here it says the sides that form the right angle are the legs. So this side forms a right angle, this side forms a right angle, therefore they are the what? Legs, and this is the right angle. Now, you should also know that the side opposite, okay, opposite means on the other side of, the side opposite the 90-degree angle is always the hypotenuse. So if I was standing right here and I threw a rock, it would hit that, so that's the hypotenuse. AC is the hypotenuse. Okay? Now, let's look at some right triangles in nature. Right here, on this bridge, this is a right triangle. Okay? That bridge builder needed to know the Pythagorean Theorem to build that bridge. Okay? This right here is a right triangle, etc. Okay? So the Pythagorean Theorem, which is the formula we're about to use, can only listen to this now, can only be used on right triangles. If it's not a right triangle, you can't use it. Did you hear that? Okay. So let's look at some more. There's the bridge from far away. Look how many right triangles there are. Right here, right here, okay, right here, right there. Architecturally, they say the triangle is the strongest shape in nature. Okay? A triangle, they say, can hold up more than a square or quadrilateral. Okay? There, I drew you the triangles so you can see them. Here's where they're right. Now, let me ask you this. What is this? The what? It's a leg. What's this? Leg. What's this? Hypotenuse. This is a leg. This is a leg because right here is a 90-degree angle. Remember, the legs form the what? The right angle. Okay. Here's another triangle in nature. You got a slide. Now, based on our formula, if we knew the distance from the bottom of the slide, or the ladder to the bottom of the slide, and the distance from the bottom of the ladder to the top of the ladder, on the formula I can tell you how long the slide was. Okay, and that's what our Pythagorean Theorem is used for. Okay, so here's the Pythagorean Theorem. Y'all write it down. Alright, so the Pythagorean Theorem is used to find a side of the triangle that you don't know. So let's say we know how long this is, and we know how long this is, but we don't know this. You can use the Pythagorean Theorem to find that third side. I'm going to prove it to you here in just a second. Now, this side, xy, is a what? It's a leg. So we'll call it A. And this side, YZ, is a leg, so we'll call it what? So your legs are always A and B. Did you hear that? Now this could have been A or this B, it doesn't matter. The legs are always A and B. The hypotenuse is always what?
C.
The hypotenuse is always C, 100% of the time. Okay? So what this formula is saying is if A is 3 and B equals 4, well, what's C? So let's say we know A is 3 feet, B is 4 feet, and we want to know C, but we don't have a measuring stick. Okay? Well, the way you do it, you plug in the formula. What's A?
3 squared.
3, so then you square it. A squared. Plus, what's B? 4 squared. And that equals C squared. So now what's 3 squared? 9. 3 times 3 is 9. What's 4 squared? What's 9 plus 16? 25. So you have 25 equals C squared. So now this is how you use the formula. How do I get C by itself? We did this on Thursday. What's the opposite of squared? Come on, we've been doing it the last 2 days. What's the opposite of squared? Take a guess. There you go. We've been doing it the last 2 days. Square root. So if I take the square root of something squared, it gets it by itself. So I got to take the square root of both sides to get C by itself. So C equals, what's square root of 25? 5. So what does C equal? So we know if this is 3 and this is 4, what's this? 5. Alright, so on this example that we have here, 6 is our what? Which is what letter?
A.
This is A, this is B, and then they told you this was C, right? So we've got A squared plus B squared is going to equal C squared. Right? Now, what's A squared?
6.
No, what's A squared? What's 6 squared? 36. And we're going to add that to B squared. What's 8 squared? 64. What is 36 plus 64? 100. Now that equals C squared. So now how do I get C by itself? Hey, this is the important part. How do you get C by itself? Take the square root of both sides, because the opposite of squared is square root, right? So you got to do the opposite. So now C equals what? 10. So what do we know this side equals? 10 what? Centimeters. Okay? Alright, so on this problem, rather than giving us, here they gave us the what? Hypotenuse, we didn't know, right? Here we don't know what a what is. A leg. So we got to find out what x is using our formula a squared plus b squared equals c squared, right? What's a? 15. And what's 15 squared? 225 plus what's b? B is x. So we're going to say x squared, and that equals c squared. What's c? So 21 squared is 441. Remember, c is always the hypotenuse, and the hypotenuse is 21 because it's opposite the right angle. You see that? The angle or the side opposite the right angle is the hypotenuse. So now you've done a million of these. We've got to subtract what on both sides? Now, why did we subtract 225? Because 225 is positive, and the opposite of positive is negative. So x squared is going to equal what? 200 and what? 2 what? 216. Okay, come on now. So now what do we need to do? To get x by itself, we have to do the opposite of square, which is what? Square root. So we're going to square root both sides. So x equals 14 point what? Okay, so x is 14.6. Now here, we're going to use the Pythagorean Theorem to find the distance from Grenada to Oxford. Okay? I'm telling you the distance from Grenada to Batesville and the distance from Batesville to Oxford, and I want to know the distance straight from Grenada to Oxford. So let's look at our Google Earth program. Now, you can see right here, this is Grenada, this is Batesville, and this is Oxford. Now, right in the middle of it is Highway 7, and it goes straight through the middle to Oxford. Okay? A real road. So we want to find out how far it is if we went straight from Grenada to Oxford. We're going to do that on our problem here. Do you understand? Okay? So we've got, here's our problem. So now tell me what A would be, because I've got A squared plus B squared equals C squared, and we're going to use the Pythagorean Theorem to find out how the distance from Oxford to Grenada. What's A, somebody? 40. So what's 40 squared? 1,600 plus 20 squared is 400, and that's whatever that is going to be C squared. So now what's 1,600 plus 400?
2,000.
We got 2,000 equals C squared. Now I got to take the square root of both sides to get C by itself. And what do I get? 44 point something?
44.7.
So C equals 44.7 miles. So is it shorter? Now think about this answer. Is it shorter to go from Grenada to Batesville and then to Oxford, or to go from Grenada to Oxford? Grenada to Oxford. Now the other question is, how far is it if I went ahead and went through Batesville all the way to Oxford? 60 miles. It's 40 here, 20 here, so that's 60. Whereas this is 44. That's a 16-mile difference, isn't it? It's almost a take a guess. So you see, we just used math to decide which road we were going to take. There's another way to use math in the real world. Two of them are a leg, and one's the hypotenuse. And the question says, determine if the triangle is a right triangle. Okay? In other words, A squared plus B squared must equal C squared. A squared plus B squared must equal C squared. So the smallest one will be A, the medium will be B, and the biggest C. So here, this is A, this is B, and this is C. Okay? But A squared plus B squared must equal C squared. So what's 9 squared? 81 plus, what's 12 squared? 144. Now, when you add those up, what do you get? 225? 225. Now, what is 15 squared? 225. So does 225 equal 225? You see how A squared plus B squared was 225? And then C squared is 225? For it to be a right triangle, A squared plus B squared must equal C squared.
India was what is known in the banking world as the second buyer. You always wanted.
Now on the second one, it's a little different because it's out of order, but that doesn't matter. We know A is the smallest number, which is 16. What's 16 squared? 256. Plus, what's 18 squared? 324. Add those up, what do you get? 841 when you add them up? 324 plus 256? No way.
Oh, 580.
So when you add them up, it equals 580. Okay? Now, this is what A plus B squared is, right? A squared plus B squared was 580. Now we've got to check what's C squared. What's 29 squared? It's 841. So now let me ask you this. Did A squared plus B squared equal C squared? Hello? No, it didn't. So is this a right triangle? No. This is not a right triangle. So you try 11 on your own and see if you can tell me if it's a right triangle or not. Go, say it, Chris. Come on.
Today we learned how to use Pythagorean Theorem.
Good.